Right, so welcome to today's lesson. For those who do not know me, I'm Tutor Post Solutions from DISCRETE Learning Institute. And today we'll be looking at the first topic in chemistry. Okay, so specifically, we'll be looking at significant figures and unit conversions. Okay, so earlier in the day, I sent some videos in the group. I told you guys to watch. So those videos were about significant figures and unit conversions. Okay, so I trust that you've watched those videos so that you may not be lost as we are doing this discussion right now. Okay, so I hope you watched those videos, or some of you watched those videos. Okay, because this session here will be basically looking at questions. Okay, questions that can come on those same concepts, but I'll try to explain whatever is going on. Okay, so if you have any questions, feel free, guys. Okay, interact with me. You can just unmute your mic and then you ask the question. Okay, and then I'll be able to help, and then we can move just like that. All right, so we'll be basically looking at questions on significant figures and unit conversions. Okay, so the first one is this one here. Okay, so the question here, they're saying how many significant figures are in each of the following numbers, these numbers that you can see here. Okay, so before you can know how to identify how many significant figures uh, a certain digit, okay, or expression has, you have to know the 5 rules of significant figures. Okay, so the first one of the rules is that all non-zero digits, okay, all non-zero digits are significant. Okay, I'll just write S for significant. All non-zero digits, so of course write digits here. Okay, all non-zero digits are significant. Okay, so numbers like 1, 2, 3, 4, 7, 6, okay, these numbers here are significant because they are not zero. Okay, so as long as the number is not zero, then it's what? Significant. So that's the first rule that you have to know. And then the second rule that you have to know is based on the zeros. Okay, in fact, all the three that are remaining are based on the zeros. Okay, so these zeros, we have about 3 types of them. Okay, so just write three zeros here, and then we'll list the types that we have here. So the first type that we have, okay, the first type that we have is what we call as the leading zeros. Okay, so these leading zeros are just zeros um, that come before a non-zero digit. Okay, so if, for example, I write a number like 0.0007, these zeros here that are in front here are what we call leading zeros. Okay, so these leading zeros are never significant. Okay, as long as it's a leading zero, then it is never significant. Okay, never significant. Okay, that's the first type of zero. And then the other one is what we call as a captive zero. Okay, so these captive zeros are just zeros in between non-zero digits. Okay, so for example, if I have 5 and then 0, 0, and then I have maybe 3. So these 2 zeros here are between two non-zero digits. Okay, these 5 and these 3. So we call them as captive zeros. Or some books they say as captured zeros. Okay, so these captive zeros are always significant. Okay, they're always significant. So whenever you see a captive zero, just know that it's what? Significant. Okay, and then we have the other type of zero, which is classified under 2 categories. Okay, so the other types of zeros are what we call as the trailing. Okay, the trailing zeros. So these zeros are just zeros that come after a non-zero what? Digit. Okay, these are zeros that come after a non-zero digit. So for example, I can write 2000 like this. Okay, so these zeros here are trading zeros because they are coming after a non-zero digit. Okay, or I can say maybe 153.25 and then 00. Okay, so these ones also will be called trading zeros. Okay, so now there are two situations. There is a situation where you have trading zeros, okay, in a number without a decimal point, like this number here. There's no decimal point here, and we have these trading zeros, okay? And then there's also this situation that I've wrote down here. There's a point there, and then you have these trading zeros, okay? So trading zeros are only significant if there's a presence of this decimal point here, okay? So if in a number you have trading zeros and there's a decimal point somewhere, then you are going to consider these trading zeros as what? Significant, okay? But if you have trading zeros like in this case, and then you can't see any decimal point here, okay? You can't see any decimal point in this number. You're going to say these ones are not significant. Okay, so these are basically the rules that you follow when you are assigning, okay, or identifying how many significant figures are in each number. Okay, so any questions there on the rules that I've explained before we do some questions there? Okay, amazing, no questions. So it means here, when we'll be identifying the number of significant figures, we'll be following these rules here. Okay, so let's do some. Okay, let's do uh, some of these here. Okay, so the first one, it's A. A, they're saying is 3.405. Okay, so how many significant figures are in this number? Anyone to help us?
4.
4. Okay, so here, this zero here is going to be considered as significant. Why? Because it's a captive zero. Okay, it's between two non-zero digits. So we're going to say this one has 4. What about this one on B? How many significant figures does it have?
3.
3. 3.
Okay. Why are these 3 zeros not significant?
Yes. They are leading zeros.
Exactly. Okay, so they are leading zeros. Leading zeros are never significant. So here we just have 3. And then here, how many significant figures do we have?
4.
3.
3. 4.
Someone said 4.
3.
So the
3.
one who said 4, why do you think there are 4 significant figures there? Hello, the one who said 4. Why do you think there are 4?
I think because there's no comma, so maybe I'm mistaken. Maybe it's 3.
So the correct answer there is 3. So this zero here at the end cannot be considered as significant. Why? Because there's no decimal point there. Okay, so you just say there we have 3. All right, so what about D? How many significant figures do we have in that number?
This number
5.
do not.
5.
Yeah, let me text you on WhatsApp. That's where my ATL number is.
Oh, someone is on the phone. Let me mute them. Okay, yeah. So this number here has 5 significant figures. Okay, so these 2 zeros here are significant because they are captive zeros. They are between this and this, which are non-zero digit, right? And then this one is significant because it's a trading zero and there's a presence of the what? The decimal point like that. Okay, so these are the basics. So you really have to understand them because I see people struggle with this tomorrow. Same simple rules. Okay, so know them from the beginning and then the rest will just be flowing like that. Okay, so this number here will have 5 significant figures. Okay, so I think you can try out this one, and this one. At the end of the lesson, I'll send solutions to all these questions so you can confirm with whatever you get. Otherwise, I'll move to another question, okay, that involves applying operations on numbers with different significant figures, okay? So by operations, I mean addition, subtraction, multiplication, and what? Division. So here, they're just basically 2 rules that we have to follow, okay? So when you're adding 2 numbers or when you're subtracting 2 numbers, and those 2 numbers have different number of significant figures, okay? The answer that you should get should have the same number of decimal places, okay, as the number with the least decimal places. So what we mean is that I will use this A here. So on A, I have 12.0550. And then I'm adding to this number, I'm adding 9.05 like that. Okay. So the rule when you're adding or when you're subtracting numbers with different number of significant figures is that you follow, the answer should follow the number with the least number of decimal places. Okay. So this one here, after the decimal point, it has how many numbers? 1, 2, 3, 4. So it has 4 decimal places. Okay. So we'll write 4 DP here. And then this one, after the decimal places, has just 2. So it has 2 decimal places. So what this means is that when you add this, when you just punch this into the calculator, just type the numbers into the calculator, the answer that you're going to get is, let me do that. Okay, so the answer that I'm getting when I add this and this on my calculator is 21.0, 21.1, I mean, and then 050. Okay, so this answer here has 4 decimal places. Okay, it has 1, 2, 3, 4, 4 decimal places. So the rule is that the answer should have the same number of decimal places as the number with the least number of decimal places. So we want our answer to have 2 decimal places. So what do? We round off from here. Okay, we round off this 5 like that. So it means my final answer would just be 21.1. And then this 5, okay, so since this is 5 or any number that is greater than 5, we add a 1 to the previous number, right? So it will be 1 like this. So your final answer should be 21.11. Okay, so that's the rule when you're adding or when you're subtracting. Your answer should have the same number as the least number having it should have the same number of decimal places as the number having the least number of decimal places. Okay, so let's try the one for subtraction. So I'm here now on B. So B, I have 257.2 minus 19.789. So we can see here that this one has 3 decimal places. This one has 1 decimal place. So it means when I subtract this, my answer should only have 1 decimal place. Okay, so I can just easily punch this into my calculator. Okay, I'm getting 237.411. Okay, so my aim now is to make this number have 1 decimal place. Okay, so I'm going to round off from here. So I'll round off this 1 to this 4. So since 1 is less than 5, I won't add anything to this 4. So it means my final answer will just be 237.4. So this is the final answer there. Okay. That's the final answer there. So that's basically what you do when you're adding or when you're what? Subtracting. Okay. Your answer should have the same number of decimal places as the number with the least number of decimal places. All right. So now let's look at the ones that are involving multiplication or division. Okay. So the ones involving multiplication or division also follow the same rule, just like the one having a positive and a minus. Okay, so let's look at D first of all, this one here. Okay, so the rule when you are multiplying or dividing numbers with different number of significant figures is that okay, the final answer should have this the final answer should have the same number of significant figures as the number with the least number of significant figures. Okay, so when you are adding or when you're subtracting, you're looking at decimal places. Okay, but when you're multiplying or dividing, you're looking at the number of significant figures. Okay, number of significant figures. So if I get this number here, 0.0577, I'm dividing this by 0.753. Okay, so the first thing is to identify or to count how many significant figures are in this number. So this number, according to the rules that we learned, it has 1, 2, 3. So it has 3 significant figures. And then what about this one? It also has 3 significant figures, right? Okay, so this entails us that the answer that we should get when we divide these numbers here should also have three significant figures since they are equal. Okay, so we're going to say, let's divide this on the calculator. Okay, so when I perform this calculation on my calculator, I'm getting 0.0776634. This is what I'm getting on my calculator, okay? But according to the rules, I have to express this number to three significant figures, okay? So what will be my number? What will be my final answer? Anyone who can try. What will be my final answer there if I express that
Zero
number?
po- 0.0766.
Okay, yeah, that's correct. So it will be 0.0766. So when we count the number of significant figures here, it will just be what? Three significant figures. So though these zeros are not significant. So this is the correct answer here. Okay, so it's just that this is a coincidence. They had the same number of significant figures. But let's try something which is a bit different. Okay, so let's maybe look at E, this one here. So I have 27.5 multiplied by 1.82 divided by 100.04, I mean. Okay, so here we have two operations in one question. Okay, we have two operations in one question. So for us to solve this one, we follow what we used to call board mass, if you remember, at grade 12 or high school. So board mass simply means brackets of division, multiplication, addition, and subtraction. So division comes before what? Multiplication. Okay. Yeah, so division comes before multiplication. So what are we going to do there? We're first going to divide or we're first going to multiply? What do you think we
Divide.
should do? What should we divide?
Divide
We divide what?
the 1.82 divided by the other one.
Okay, yeah.
Divide.
So let's start. We start. So you're saying we start with this, right?
Yes.
Okay, let's divide. So we have 27.5 multiplied by the answer that will come out from here. So let me just punch this into my calculator. Okay, so what do we get? So 1.82 divided by 100.04. So when I do that, what I get is this. I get 0.01819272291. Okay, so this is what I get. So here now I was dividing. So the answer that I should get when I divide, okay, should have the same number of significant figures as the number that had the least number of significant figures. So here, this one here has 5 significant figures, and then this one has 3 significant figures. So it means my answer when I divide this should have 3 significant figures. Okay, so I'll come and round it off somewhere here so that I round off this 9 here. So the answer that I'll get will be 0.0182. So this one here has 3 significant figures. So it's the one that I'll write here to be 0.0182. I hope you're confirming with your calculators as well. Okay, so that's the answer we get from there. And then now we can multiply. So let's multiply this and that. Okay, so I have 27.2 multiplied by 27.5
That's my element.
multiplied by 0.0182. Okay, so I get 0.5005. Okay, so here, since we're multiplying, we still follow the same rule. So we are saying this one has 3 significant figures. Even this one here has 3 significant figures. So it means even our answer there should have 3 significant what? Figures. So when we round it off to 3 significant figures, what are we going to get there?
0.501.
501. Yeah. So our answer is going to be 0.501. That will be our answer there. All right. So that's basically what you do. Okay. So when you are adding, subtracting, consider the number of decimal places. When you are multiplying or dividing, consider the number of what? Significant figures. Okay. So I'll leave these others for you to try, but I'll send the solutions to all these. So you try and then you compare to whatever I found. Okay, so let's move on to other questions. So here they're saying this is just rounding off. I believe we don't have anyone who has a challenge on rounding off. But anyway, let's do 2 or 3. Okay, so here they're saying rounding round each of the following numbers to 3 significant figures. Okay, so the first one is 342.79513. So we're rounding off these to 3 significant figures. So we'll round it off from here. So we're rounding off this 7 to that 2, right? So what are we going to get? We're going to get 3, 4, 3. It's correct, right?
Yes.
Okay, so that's what we get on A. What about B? What about B? Okay, so B has the 9,845.8749. So we want to round this to 3 significant figures. Okay, so what are we going to get there? What can be the answer?
9, 8, 5.
8.
9,
Nine,
8, 5.
985 what?
985.
That's all?
0.
No,
Okay.
9.850.
985.
So I was saying 9.85. Okay, so this is a comma. This is not a point. This is a comma. Like this is 9,845 point. Okay, so when we round it off to 3 significant figures, it means we are rounding off from here. Okay, so the rest here will just become zeros. So what we are going to have is that we're going to have 9, 8, and then this 5 will round it off like that. So it becomes 5, and then while there's 5 there, I'll just put 0. So don't add this point here and then you write other zeros, because if you write point and then you write other zeros like that, it will mean even these are significant. Okay, so you just end it per 9850, then you end like that. So it means this one here has 3 significant figures. Okay.
What if you don't add the 0?
Yeah, if you don't add the 0, then you've changed the numerical value, because this is like 9,000. So 9,000, the 9 has to be followed by 3 digits if it's in thousands. But if you write, for example, 985, this will be 900. So you change the numerical value.
Oh, okay. Thank you.
All right. Amazing. All right. Let's do C. C is interesting because there are a lot of zeros there. So how can we round that off to 3 significant figures? So I have 0.000045389. How can we round off this number to 3 significant figures?
A round of 8.
We round off what?
8.
4.
Okay. We round off from where? Where should we round it off?
8 and 3.
To the left.
Okay.
It is 8 to 3.
Okay,
Then
so
it becomes 4.
we are rounding off from here, right?
Yes.
Okay, so we are going to have 0.0000454. Okay, so we have rounded off to 3 significant figures. Okay, but another clever way in which you can do this is using what we call scientific notation. Okay, so you can move this decimal place until you reach somewhere here. So we are going to say 1, 2, 3, 4, 5. So I've moved 5 steps to the right. Okay, so it means my number is now 4.539 times 10 to the power
Times
how many times
to
did I
the
move?
5
Okay, so because
minus
Negative
5.
5.
so because I was moving to the right, the power should be -5. If I was moving to the left, the power should be positive. So it's like opposite. If you move to the right, negative. If you move to the left, positive. And then here now I can round off. So it will be 4.54 times 10 to the power -5. So you can see that it's better to write it like this than this. This will waste your ink because you have to write all these zeros. But here, just write it smartly like that. You've seen it.
Yes, sir.
All right. So now let's look at the last question, which is on unit conversions. Okay. So unit conversions, basically, you just have to know the conversion units. Okay. If you don't want to memorize the conversion units, you have to study the metric system. So I sent a video on the metric system so you can watch. You know what the prefix mean, then you'll be done converting any unit. So like here, the first one, they're saying how many milligrams are in 45.9 grams? Okay, so it means we're changing this to milligrams. So how do we change that 45.9 grams to milligrams? We just have to know the
Multiply by 100.
exact, multiply by what?
1,000.
Okay, yeah. So you multiply by 1,000. Okay, so we multiply by 1,000 because the prefix of this will be 10 to the power -3. Okay, yeah. So you check your metric system, or you can say 1 gram is the same as 10 milligrams, or you can say 1 milligram is the same as 10 to the power -3 grams. So this 10 to the power -3 grams is the same as 1 over 1,000. Okay, so you can use any of these two to convert. So here, since we have 45.9 grams, so we don't know how many milligrams, we can put X. And then now we know that 1 gram is equals to 1,000 milligrams. So we can cross multiply. So 1 multiplied by X multiplied by 1, I get X is equals to. And then here, what am I going to get? Or maybe I should be putting the units. So here I'm going to get X gram is equals to, and then here it will be 45.9 grams multiplied by 1,000 milligrams. So I can divide both sides by this gram. So this gram is going to cancel with the gram. So it means X is equals to this number multiplied by 1,000. I'm just going to get 45,900 milligrams. Okay, so that's how we can convert that one. Unless there are any questions, I'll move to the next one.
We
Okay.
can move to the next question.
All right, all right, all right. So let's look at the next one. So the next one, the conversion units that we are using here, we are looking at milliliters and liters. Okay, so we know that 1 liter is equals to how many milliliters?
1,000.
Exactly.
1,000 milliliters.
Okay, so like that, or you can say 1 milliliter is equals to 10 to the power -3 liters. Any of these. So there we have 0.009987 milliliters. We want to convert it to liters. So we can write X here. And then we know from the conversion factor that 1 milliliter is equals to 10 to the power -3 liters. And then we cross multiply. So cross multiply, I get X milliliter is equals to this number multiplied by this. Okay, so what am I going to get? Okay, so I have 0.000987 multiplied by 10 to the power minus 3, and then I have milliliters multiplied by liters. So when I cancel this, even this one goes. So it means my x will be equals to this number multiplied by 10 to the power 03. Okay, so what I can do here, I can be smart. In fact, I can solve this without even using a calculator. So I can move this 1, 2, 3. So if I move it 3 times, it means I have 9.987. Okay, and then times 10 to the power minus 3 because I was moving to the right. And then I also have this 10 to the power minus 3 and then liters. So it means my x will just be equals to 9.987 times 10 to the power. So these ones have the same base. So I can just add their powers. So that would be minus 6. And then I put liters. So that would be the answer there.
Sorry, sir, can you please repeat?
Okay, so I was saying here you can be smart. You can answer this actually without even using a calculator. So what I did is that I expressed this number here in scientific notation. So I moved the decimal point from this part 1, 2, 3 times. Okay, then when I move it 3 times, it means the number now becomes 9.987 times 10 to the power. How many times did I move it? 3 times, and I was moving it to the right. So the power there will be negative. And then I have this same expression being multiplied by 10 to the power minus 3. And then I have liters. So this 10 to the power minus 3 and this 10 to the power minus 3, I'm multiplying them. So they have the same bases here, 10 and 10. So it means I can just simply add minus 3 and minus 3, which gives me minus 6 there. So that's how I got this answer.
Why are there two tens
Okay,
minus
thank you.
3?
So this
Sorry,
other
sir.
10, this other 10 to the power minus 3 is coming from the conversion factor, this one here. And then this other 10 is coming from when I expressed this number here in scientific notation. That's where the 10 to the power 3 is coming from. Have you seen it?
Thank you. Yes.
All right. Amazing, amazing. Okay, so let's solve one last question, and then we can call it a day. We're just starting, so we don't have to discuss a lot. Okay, so the ones for Kelvin, these are simple, but let's try to do this one here. So I have 2, 3, 4.5. Yeah, what am I writing? 2, 3, 4, 5.98 meters. Okay, so I want to convert this to centimeters. Okay, so how can I do that? So I know my conversion factor is just 1 meter is equals to 100 centimeters. So what I do here is just 2345.98 meters is equals to x. And then I have 1 meter is equals to 100 centimeters. So cross multiply, I get x is equals to this number multiplied by 100. Okay, it's just going to give me 2, 3, 4, 5, 9, 8 centimeters. Okay, so I've converted, and that's all there. That's all there is. And then these ones for temperature, they are very simple. Just use the formula to convert from degrees to kelvins. You say the temperature in kelvins is equals to the degrees, the temperature in degrees, I mean Celsius degrees, plus 273.15. So you just use this formula. So I'll send a video.